Hello everyone, my name is Max Beal and I work with Dr. Paul Block in the Water Systems and Society Research Group, and today I'm going to talk a little bit about our development of season-ahead cyanobacteria biomass forecasts for Lake Mendota. So cyanobacteria are photosynthetic aquatic microorganisms that can produce toxins that pose a threat to our recreational economy, our lake ecosystems, and human and animal health. And these are a pretty familiar threat on our Madison lakes. Each year we see a similar wave of news stories come out highlighting these issues. But of course, these aren't only an issue on our Madison lakes. We've seen concerning global trends in the proliferation of cyanobacteria with climate change and a susceptibility of our Great Lakes to cyanobacteria blooms. But rather than talk about long-term trends in cyanobacteria, today I'd like to talk about cyanobacteria variability over a year, and more specifically in spring and summer. Summer being the peak season of cyanobacteria productivity in the northern hemisphere, and spring being an important season setting up the conditions for that productivity. So we know that variables like frequent and intense precipitation events, warm temperatures, and high phosphorus loads in the spring, combined with available sunlight, low grazing by zooplankton, and stratification strength in the summer, can set up conditions that are favorable to cyanobacteria and cause them to proliferate. So our question here today is, can we use these local scale variables that I've just outlined and larger global scale patterns that modulate these local scale variables to forecast cyanobacteria biomass ahead of the summer season? And why do we want to do this? Well, ideally, by creating these forecasts, we can provide information on water quality conditions ahead of this sort of high-risk season. And so hopefully, lake managers and public health officials can make different decisions like changing summer budgeting, altering testing routines, or training lifeguards differently, and just generally this can also increase public awareness about this public health threat. So the way that we develop these forecasts is that we start in the spring by developing a set of preseason predictors, fitting them into a statistical principal component regression model, and coming up with a probabilistic forecast that gives us an idea of what we can expect cyanobacteria to look like in the coming summer compared to historical observations. But we don't have to stop with just one forecast. As spring moves into summer, we can identify a new set of predictors from the late spring and early summer months, fit them into a new principal component regression model, and come up with a second sub-seasonal forecast. And ideally, this sort of system of forecasts might give decision makers a number of information points along the sort of spring-summer continuum to inform decision making continually. But a really important part of this process, of course, is validating these models to make sure that we have the most accurate forecasts possible. So here's an example of our validation process for our July-August cyanobacteria forecast. The figure that you can see at the bottom here is a hindcast, or a representation of how well our forecast does historically. Each of these little boxes is our range of predictions for that given year, and that thick black line represents observed cyanobacteria biomass concentrations averaged across July and August for that year. And hopefully what you can see here is that we have a pretty good fit between our predicted cyanobacteria biomass and the observed cyanobacteria biomass. And we do especially well in predicting the above normal cyanobacteria concentrations, which are of most concern from a public health standpoint. So that's all I have for you today. Thanks so much for listening, and if you're interested in checking out our forecasts, please take a look at our website and keep an eye out for our summer cyanobacteria forecast coming in early June. Thank you.